We are going to discuss about water, subsurface water, groundwater, and groundwater bearing characteristics of geological formations which are manifested by types of formations which could be aquifers, aquifers, aquiclude, etc. Water, the most fundamental life supporting system on earth. It occurs generally in rivers, lakes, oceans. The moment it enters below surface of ground, maybe by process of infiltration, which is the first incidence of movement of surface water to groundwater, and further down by process of percolation, then it becomes subsurface water, not groundwater yet. For it to become groundwater, there are certain adjectives which it must fulfill. We have a look here. The water infiltrated, the first incidence of movement of surface water to ground subsurface system is infiltration. It further percolated down by percolation, then reached here and saturated all this. The top of the saturated zone is water table, where atmospheric pressure is equal to hydrostatic pressure. Now in this particular saturated zone, everywhere all the voids are fully saturated with water. There is no air. They have been pushed out of the system. While in vadose zone, you have both air and water in the voids. Now this saturated zone is groundwater. And the whole is subsurface water. So groundwater is a subset of subsurface water. Why are we talking about this? When we were trying to talk about groundwater bearing characteristics of geological formations. Because henceforth, we will be trying to understand the groundwater bearing characteristics of such geological formations where all voids are saturated by water. Now, why will a formation bear water? What will help it in doing that? The first, porosity, volume of voids by bulk volume of rock, VB, let us say. Then, is it enough that if a rock is porous, then it will yield water? If it is porous, it can hold water. For it to yield water, we must have the pores which are interconnected. And the interconnected pores are measured by permeability, that is volume of interconnected pores vis-a-vis volume of the formation. Even then, we need to have transmitting capability of the aquifer, conducting capability of the aquifer, which is measured by hydraulic conductivity, and there are other formation properties. Coming down to the point, a geological formation which can store and transmit or conduct water in sufficient volume for economic exploitation, or which can be exploited economically, that is aquifer. That is aquifer. And a formation which can neither store nor transmit water, that is aquifers. Needless to mention, aquifer will have sufficient porosity, sufficient permeability, and sufficient ability to transmit water, while aquifers, most of the cases, neither have porosity nor permeability. The types of geological formations which have this is granite, where you have intercrystalline grains, so there are no voids, and when there are no voids, needless to say, they will be interconnected. Aquifers are sandstone, loosely lithified sandstone, non-indurated riverbed sand deposits where they have enough porosity and permeability. In between these two end members, we have formations which are aquitart. They have ability to store water and limited ability to transmit water, very often in one direction. Could be sandy clay, mixture of sand and clay, so that is an aquitart. Aquiclude, it has porosity, but the pores are not interconnected. And the best example in world is clay, which has high porosity. It soaks water, becomes sticky, but cannot transmit water. It's a miser, head of the family, earning a lot of money and distributing none to the peers, none to the family members. That's a clay, aquiclude. Now, we intend here to discuss about the aquifer, which is the most fundamental thing in groundwater science. What is this? It is a formation which has the ability to store, transmit and yield water. But are there types of aquifers? Yeah. The nature itself gives few types of aquifers. And the best would be if I make a transit from Himalaya to Delhi, cross section, and many types of aquifers are seen in this cross section. I think it becomes clear. Have a look here. This is Shivaliks, and then the Bhabhar or the Piedmont zone in front of Shivaliks, a very narrow zone. And then you have the Tarais, and then the axial plain, that is where you have the floodplain of river, oxbows, meander and cuts, so many things which a river makes. It creates its own regime. When you will have a look down surface, subsurface look, you could have a thing like this. Sand may be occurring if this is Meerut. A sand may be occurring at depth of say 200 meters, which is capped by a clay aquiclude. So you have clay, you have sand, and then there is another sand which is right from the surface. Now, what difference it makes when a sand is sandwiched by two clay layers, clay at the bottom and clay at the top? And what difference it makes when a sand is sitting on a clay but exposed to atmosphere through soil? It makes a lot of difference. This is locally open system, this is locally a closed system, which gets all its recharge and input into the system some 200 kilometers down. The input is from Piedmont zone. Here you have input into the system right in situ input. The aquifers which are bounded on top and bottom, which are confined on top and bottom by impervious layers, are confined aquifers. Impervious layers like clay. They are confined aquifers. Then the aquifers where the bottom is an impervious layer but the top is directly interacting with atmosphere, that is an unconfined aquifer. Somebody can make a point. Why the hell this matters? It's confined, fine. It's unconfined, fine. Why should we think about this? The very confinement gives rise to a different pressure setup in a confined system. Very often, the pressure is so high that if you puncture this, then the water gushes out to the surface and you have free flowing wells at the boundary of Bhabar and Tarai. While in an unconfined system, the pressure dynamics is different. Then in between, you can have often purged water bodies where local clearances gives rise to local saturations. So you can have confined aquifers, semi-confined aquifers. I didn't explain what is semi-confined, where the top layer is not fully impervious. It transmits some amount of water down, but doesn't allow transmission of water, allow water to be transmitted like this. So that is semi-pervious. So we have types of aquifers: confined, this one, unconfined. Then this can get converted to semi-confined and purged. The last point is that the water table, which we generally hear of, is the top saturated horizon of an unconfined aquifer. For a confined aquifer, the imaginary surface which joins all the water heads, if it is punctured, is a piezometric surface. In nature, the pressure difference between the two determines which water is being pushed on which side when it is pervious, slightly pervious. So with this, we sum up.